What we're looking at today is Cramer's rule. Now, Cramer's rule uses determinants to solve systems of equations. Let's see the coefficients matrix of the system ax plus by is equal to m, and f of x plus gy is equal to n. So this here would be the matrix C. And they're talking about here and here. Now, whenever we're solving x, we're taking what the equation's equal to, replacing those with the x values in the matrix. When we're solving for y, we're taking what the two equations are equal to and replacing the y values in the matrix with those there. Simplifying, then we have our answer for the values of x and y. Well, let's actually look at this and see how this works out. Solve the following system by using Cramer's rule. Well, x is equal to so we're going to have two determinants. Now, the determinant on the bottom is just going to be the matrix of the coefficients of the variables. So when we look at the first one, well, we have 5x minus 6y. So we would have 5 and negative 6. On bottom, we would have 3 and 4, because those are just the coefficients, the numbers in front of the variables. Now, since we're solving for x, in the top one, I wouldn't have the values of 5 and 3, the values of x. We're going to have what it's equal to in their place. So since the top equation is 15, it would go on top, and 29 would go on bottom. And we would keep the values of y. Questions on how we set up x? Now, when we set up y, because we're going to have a determinant on top and a determinant on bottom. Now, the determinant on bottom will be the exact same. 5, negative 6, 3, and 4. Because C is going to be the same. It's just going to be the determinant of our coefficients, the numbers in front of the variables. Now, when we plugged it in for x on top, we replaced the x values because that's what we're looking for, yes? For this one here, we're going to replace the y value. So we'll have 15 and negative 29. And the x values, 5 and 3, will stay the same. Any questions on this here? Well, now we just need to find the determinants and solve. Or just simplify each one, and we would have our answers. So let's look at x first. We'll solve x all the way down, and then deal with y second. Now, because this is a second-order determinant, we're just doing the cross. So on top, we're going to have 15 times minus negative 6 times negative 29. On bottom, we're going to have 5 times 4 minus negative 6 times 3. So on top, we would have 15 times 4, which is 16, minus negative 6 times negative 29. 4, carry the 5, I think it's 174. On bottom, we're going to have 5 times 4, which is 20, minus negative 6 times 3 is, we're going to have plus 18. We have 3 negatives. We have the subtraction and then the 2. Okay. Well, 60 minus 174 is negative 114. 20 plus 18 is 38. It'd be nice if negative 114 divided by 38 evenly. Huh? So the value of x is negative 3. Questions on this here? Yes, sir. Yeah, I mean, this point here, we could have done that. In the calculator, we would have had to put matrices A in, well, we can call it C, in, and let's see here, rewritten as x is equal to the determinant of A over the determinant of C, and that should be able to give us the answer. Or we could have taken the determinants individually and then divided them. It would also given us the answer. Questions on this here? We ready to solve y? For y, yes? So y is equal to, so we're going to do the cross for the top, which would be 5 times negative 29 minus 15 times 3, yes? And what would we have on bottom? Well, we would. And what would that be? Because we already found it, didn't we? Because we could do that multiplication out and work it all the way through, but we already solved it once. We found in x it is 38. The denominator, the determinant for the denominator for y is the exact same as x. So we could do that multiplication, or we can just plug in the answer that we know. Is equal to 5 times 29. 5 carry the 4, negative 145 minus so y would equal negative 190 over 38. And I want to say negative 5. So the solution for this is the point negative 3, negative 5. Questions on this here? Ready for the next one? Let's do one more of the 2 variable systems. Do we want to do A or B? B? So we can look at this in the calculator. Because if I want to solve for the value of x, we're going to have the determinant on top. Going to need a little more space than that. And the determinant on bottom, yes? Now the determinant on bottom is going to be 8, negative 5, 9, and 7, yes? The determinant on top would be what? Almost. 37 and negative 1 would go first. Because if we're solving for x, we replace the x values.
You just mixed them together.
Oh, geez. Thank you. 70 and 3. Yep. I got that too close to the first one and just was going right down. Yeah, so you're right with 70 and 3. And then our next numbers would be? 5 and 7. Okay, let's see if I can try not to do that again. So for y, well, the denominator would be the same. The numerator, well, we're going to take 8 and 9, and then 70 and 3, yes? How many different determinants am I taking here? 3, because we have the 2 numerators for x and y. The denominators in both are the same. So when we plug it into the calculator, and we'll plug it in here in a minute, well, we can set matrix A as 70, negative 5, 3, and 7. We can set matrix B as 8, 9, 70, and 3. And C as 8, 9, -5, and 7. It doesn't matter which ones we pick, but we just need to define each one of those 3 into the calculator. So we can go to the calculator and do second matrix, and go over to edit, and we'll edit in the B 2 by 2. We'll have 70, 3, 7. So we'll type the first one in. Once we get the first one typed in, we can go second matrix, over to edit, and down to matrix, which will be a 2 by 2 still, and we'll have 8, 70, 9, and 3. And once we get it plugged in, we're going to go second matrix again, but this time we want matrix C, and this one here is a 2 by 2, 8, -5, 9, and 7. Questions on this here? Once we get them all typed in, we can go second quit. Now we can find these individually because I can take the determinant of all 3 and then divide them by hand, or we can have the calculator do it for us. If we let the calculator do it, we're going to go alpha y equals enter. Actually, hit clear. Let's do it this way. I learned this way actually just this last Saturday. Go alpha and then hit the X, the button we normally get X with. Okay. Let's see here. Is it alpha? Yep. I think it gave some of us a... Okay. Because for some it'll give you a fraction. For us it's not. So we have to do alpha y equals enter. For the, I think you're on a newer software. For some of the graphing or the color calculators, alpha x will do the same thing. Unfortunately for us, it doesn't. Yeah, I didn't know until this last weekend. Yep. Now, what do we want on top? We want the determinant of A, yes? So we can go second matrix, over to math to get the determinant, and then we want second matrix A. So we have the determinant of A over the determinant of which one? Determinant of C. Because we picked matrix C to be inputted as the coefficients. And if we hit enter, we find the value of x is 5. Questions on this here? Now, what we can do next is that we can go back in and do alpha y equals enter and pull up a fraction, yes? But what is the only thing that we're changing from the one we just did? I'm putting B into A, yes? What we can do is if we hit up twice and highlight it to where it's probably like a black box around it, hit enter. It copies it back, doesn't it? And what we can do now is we can actually go back, cursor back over where it's kind of selecting A, or at least the first bar. Did y'all see that? Now, once that's selected, let's go second matrix B. Because what it'll do is it'll tear over the top of it. It'll clear it out. It's the same as having the insert key selected on the computer. If you ever used the insert key, if you ever hit it, it just starts typing over the top of everything else, inserting it in. It's not a fun key to have typed, because if you start typing from wherever it's at, it'll delete as it fills in. But we can go on and hit enter, and it's -6. Questions on this here? So our solution is 5, -6. Questions on this here? Is this the most effective way to solve two variable systems? Not really, because our reduced row epsilon form, RREF, pretty much gave us the answer, and we only had to type in one matrix. Did y'all get 5 or -5?
I got 5.
See here. 15. Gets on bottom -5 times 9. 6. Since we're doing it with x, these values need to go in place of x. And these, so you have these. We took the 2 equal to x. Yeah, you just had those flipped. Does that make sense? Because for x, let's do, we'll go in place of the x values. Go in place of the y's. You just had those 2 swapped. We can also do this with 3 variable systems of equations. Now, for 3 variable systems of equations, we're doing the exact same thing. Because when we're solving for x, we're taking the 3 x values and replacing them with what it's equal to. The same for y and the same for z. And it's all over the matrix. So the determinant of the matrix of the coefficients of the system of equations. So when we look at this here for x, on top, we're going to take the x values, which is the 437, and replace it with what it's equal to. So it'd be -14, 47, and 15. The rest of the values would say the exact same, because we're only replacing the x values in each one of the equations. On bottom, it'll be the values in front of the variables. We'll do the same for y, except for this on top, we're replacing all the y values with what each one of the equations is equal to. I'll scroll back up here in a minute. As we'll have to do the same for Z. We're going to have 4 matrices this time. And this one here, I would definitely plug into the calculator. I wouldn't try to do this one by hand because it's a lot of work to work out. So we can come back over here. And we go second matrix over to edit. We'll just edit matrix A, which would be a 3 by 3. Negative 14, 5, negative 6, 47, negative 2, 7, 15, negative 6, negative, and this would give us our first matrix, the value of the numerator of x. Then we can go to matrix over to edit, and this time we can do matrix B, which I don't need a 4 for any. 3 by 3. Then I can have 4, negative 14, negative 6, 3, 47, 7, 7, 15, negative 8 would be the second matrix, top of Y. Then we can edit matrix C. 4, 5, negative 14, 3, negative 2, 47, 7, 6, 15. Matrix C, and then we've got to do it one more time for matrix D. Again, 3 by 3, 4, 5, 6, and then 3, 2, 7, 7, negative 6, negative 8. And we have this here. Questions on how we got this? Second quit. We can go alpha, y equals, enter if we want to, or I can grab this again. Now, are we actually wanting matrix B over matrix C? No. So I can highlight B and go second matrix A, second matrix D, because our new denominator is D. I just chose the last one. And we can go enter. So for this 3-variable system, the value of x is 5. Then we can change matrix A with matrix B, which tells us that the y value is -2. Sure. Matrix C B4. So our solution is the point -5 or 5, -2, 4. Any questions on this here? And that's really all we're doing with these here. Those are the 4 problems, but I made up a worksheet for them instead. Next week, you can pass all those back. Possibly Wednesday or Thursday, one of the two. Yeah.